Hello everyone and welcome to our tutorial number 6. And today we have a topic of TR-398, which is the first performance standard developed by the Broadband Forum for Wi-Fi. So I'd like to introduce our speakers. We again have with us our CTO, Leigh Chinitz, who has been in the data communications industry since the early 90s with all the key companies. One of the pioneers in Wi-Fi, Proxim, and Cisco and CASA systems, other technologies, including UMTS, CDMA, femtocells, small cells. Leigh has done a lot of work in the standards organizations and with FCC. He's most recently been contributor to the Wi-Fi Alliance, IEEE, TIA, and ITU. We have with us today to run some tests for us, Prachi Somkuwar, who's our systems engineer. Prachi works with our customers in the Bay Area in California, and she's our expert on the Wi-Fi Alliance testbed, and now she's quickly becoming an expert on the TR-398 testbed, so we'll have to amend your bio, Prachi. And so we're holding these sessions live 3 times during the day in order to reach all the time zones, and so we can interact with our audience, with you folks live, and get your questions live. So you're welcome to post notes and questions either in the chats or in Q&A, or raise your hand. If you need help with Zoom, let us know and we'll help you out. And with that, we're going to get started. We'll let Leigh take the floor.
Hi, everybody. And again, thank you all for joining the now 6th in our series. I guess everybody has watched everything on Netflix at this point, and so we're happy to be able to provide you some other content to entertain yourself while we're all staying at home and being safe. So I noticed from that poll that maybe 1/4 of the people were not familiar with Broadband Forum and TR-398. So let me give a little introduction to the whole idea here. And I'm going to start by discussing the difference between an interoperability test and a performance test. Really in the communications industry in general, and probably many industries, interoperability is really the first thing that you really need to worry about. And we hear a lot about interoperability testing. It's very important, especially when you are looking at standards like, Wi-Fi and others, where you'll have multiple vendors all creating products with the intention that those products can communicate with each other. So the important first question to ask is, can my device that I made and I believe is in conformance with the standard talk to your device that you made, which you think is in conformance with the standard, and can they work together, and can they make something happen? That's kind of the first level that we get to. A performance test is a little bit different. A performance test says, all right, once I know that the devices can communicate with each other, now I'm interested in knowing how well that works. Is it, just for sort of basic communication, or is it, really advanced and able to provide, really an excellent service? So that's the difference between interoperability and performance. In the Wi-Fi industry specifically, interoperability is the thing that we kind of all talk about most of the time, right? We talk a lot about the Wi-Fi Alliance. The Wi-Fi Alliance has done amazing work, really, in making Wi-Fi the standard that it is. This is a little graphic from them talking about everything that's happened since around 1999, when the first, 802.11b spec hit the market. Since then, they have been driving the market in terms of not only marketing, but really just making sure that with each advance in technology, the products continue to be interoperable. And, you know, it's had amazing success. I don't think it's necessary to really belabor this point. I always like to point this one out, and just in case anyone didn't see it, I just think this is a great survey came out of the UK that said that Wi-Fi was the best invention of the last 25 years, beating things like the iPhone and Google. And, you know, I think we all know why that is. I mean, it's penetrated everybody's life, and interoperability is a huge reason for that. Interoperability, though, has one potential downside, if you want to think of it as a downside, which is that a person then looking at purchasing a device now has many options, because the interoperability regime is so well done that many different companies can build products that will interoperate, and a person needing to decide now what product to use for any specific application will be confronted by many options. So you have a lot of products to choose from. You know, no matter what part of the system you're looking at, right? Whether you're looking at access points, gateways, extenders, station devices, client devices like phones or laptops, whatever it is, they all work together. Now you need to decide which one to use. So that's where performance testing comes in. At Octoscope, by the way, we actually we support both of those activities, not only just in terms of our kind of support for them, because we think they're important, but we support them from a product point of view. We have a test bed that is specifically aimed at helping companies to look at their products in terms of the Wi-Fi Alliance certification process. We call it a pre-certification test bed. It's shown there on the right. I think we've probably spoken about it in some other of our tutorials, but anybody interested in hearing more about it is welcome to contact us. I'm happy to talk about it. It's not what we're going to talk about today. We're going to talk today about our support, again, both from an activity point of view and a product point of view, in terms of performance testing. And specifically, we'll be talking about the standardized performance test plan known as TR-398 from the Broadband Forum. And we'll discuss how we implement those tests in the system shown here on the screen. You know, any of you who've attended some of our previous tutorials will know that we like to mix in not only me sort of talking about various things, but and other people as well, obviously. And but we also like to mix in actual demos. We like to show you the tests running and things like that. For this seminar or tutorial, we've done it a little bit differently. We are going to do that. But before I explain everything, we're actually going to start a test. And the reason for that, and I'll describe why later, is that the tests themselves are quite long. And so what I want to first do, and it's a little bit out of order, and I'll describe more about the Broadband Forum later for those of you who aren't aware of it and things like that. The first thing I want to do is just give you all a sense of what this performance test plan looks like coming out of the Broadband Forum. It's made up of 11 tests, 10 of which are mandatory, and they're sort of highlighted in here, broken into 4 different categories of general performance, coverage, multiple station performance, and then overall stability of the product. You can see the individual tests here. I'm not going to talk about each one individually. Anyone who wants the slides has them. You can also look at the test plan itself. It's freely available. But again, basically performance looks at things like throughput and you know, the number of devices that can be supported. Coverage looks at things like rate versus range and rate versus range with orientation. Multiple stations looks at things like, as the name implies, how an access point is able to handle multiple stations simultaneously. And stability, again, looks at things like if you want to run a test for quite a long period of time, for example, is the device able to handle that type of test. So these are the tests that make up TR-398. As I just said, these tests can take a really long time to run, and I will describe for you a little bit why that is, but just in general, it's because the tests themselves are made up of many different subtests. A very simple example would be that a test might be made up of a test in the 2.4 gigahertz band and a test in the 5 gigahertz band, and that same test in the uplink direction and the downlink direction. So a single test may be made up of 4 what I call subtests, but it is that's actually one of the simpler ones. There are much more complicated tests that may have not 4, but more like 8 or 12 or 16 subtests. So these tests can take a very long time to run, and there's just no way to do an entire test within the time frame of this. And we don't really want to bore you by kind of showing you this. So what we're going to do is we want to start a test at the beginning, so you can kind of see how it starts. You can get a sense of what it all looks like when we're running it. Then I'm going to describe it in more detail, and then we'll come back later and look at the results. We picked one of the multiple station performance tests because it actually highlights a lot of the key attributes of the system that we're using. This test requires station devices to be at different distances. I have distances in quotes because it's the way we do our testing, obviously, is in our isolated chambers. So it's really attenuation or path loss between the devices and the access point. And it also requires many stations. We use our virtual station capability to do that. So let me, I'll get into that in more detail. Like I said, what we want to do here is give you a sense, and then we actually want to show you the test running. We'll start it. We'll come back to it later. So let me give you a quick visual description of what this multiple station performance test is looking at. What it's looking at is the ability of an access point to support, as per the name, multiple stations. So we start off doing the test with 3 stations at a fairly close distance to the access point. And we run traffic to all 3 of them, and there's an expectation that there will be some aggregate throughput on this link. So the sum of the traffic going to each station will be something, and that should be higher than some limit. We then add 3 more stations, but those stations are actually further away from the access point. And because they're further away, they're likely to have a lower data rate. And then we look again at the aggregate traffic between the access point and all 6 of these stations. And because we have some stations at lower data rate, we would expect the aggregate throughput to be somewhat lower, but there's some defined threshold by the group. And then the last part of the test is we add 3 more stations even further away. Again, these are likely to have even lower data rates, and therefore the aggregate traffic to all 9 of these would even be lower, but it's expected to be at some level. So that's the test we're going to run, and I'm going to hand this off to Prachi now to start us off so you can see the test running. We'll come back. I will describe more about TR-398, more about the tests and things like that, but this way you can get a first look at how it looks when we run these tests.
Thank you, Leigh. So what I've done is I have already started the test on the command line here, if you can see. So right now it's running a 2.4 gigahertz short distance test in downlink direction. So on the UI, you can see that we have 9 stations. And if you see here, we have enabled the virtual station capability of our PAL6. So each of the PAL6 is configured as 3 virtual stations. So right now, you can see the plot of 2.4 gigahertz downlink short distance. And after that, what will happen is we will enable additional 3 virtual stations in the medium range with additional attenuation. and you can see the run on the UI. So it's showing that it associates, and as soon as it starts running, I could show you the different statistics on the UI. So many of you might be familiar with the UI, but I'll just go through it again. So the advantage of using PAL6 as our endpoint is we get to see the other underlying metrics apart from the throughput. So you could see that we have the throughput here. We have throughput from each individual virtual stations, and the black one is the aggregate. You can see the RSSI, you can see the data control RSSI and data RSSI per chain. And we can see that it has refreshed the page, and we are running a short and a medium distance throughput now. So apart from the RSSI, we can see the data rates, MCS, the number of streams, and bandwidth. So yeah, this is one part of the entire TR-398 test. And after this, we will run a short, medium, and long distance test, and we will continue to 5 gigahertz tests. So I think we will come back to the results after the run is completed, and Leigh can go over the results with you guys. So Leigh, can you, should I stop sharing and you can take over the screen?
No, let's hold on just a second. So yeah, so everybody, as you just saw here, this test is running automatically. We're using our automated framework. We've created, all the automation for all these tests, and you can see what's nice about this is that although the test is running automatically and you don't actually have to do anything, you can see that the test itself does get created and is made visible in the UI. So you can watch it, but you're not actually required to do anything. You don't have to watch it either. I see that there's a question, and before we leave the screen, let's see if the question is related to the screen. Do we want...
It's not, so we can finish on the screen.
Okay. I will take a screen back then.
I would also add all these tests are saved in our database in MongoDB as you run them, as well as exported results. Now the question is from Isaac, and he's asking, what incremental distancing are you using for the stays?
I don't remember the actual numbers off the top of my head, but the nice thing about TR-398, and I'll get into this a little bit more, is that the tests themselves are well defined. So it's something like this. The basic configuration for TR-398 test has the station device being, and I will say in air quotes, 2 meters away from the access point. It's again specifically defined in the spec that it's either 2 meters physical distance or the equivalent of 2 meters attenuation in free space. So. And that's because we use multiple chamber environment. We actually have we use the 2 meters free space definition, and then these incremental distances are just defined in the spec. So I think that the short distance is 2 meters plus 10 dB, and then the medium one is something like 2 meters plus 30 dB, and then the long one is 2 meters plus 40 dB. It's something like that, but that's kind of how the spec is written. It sets up the tests and then tells you what you need to do.
Okay, we have one more question from Michaela. If we do not use the PAL as an end device, then what information of the GUI we can get? I guess there are two parts to that in this context, in this test, and in general when we run the tests, right?
Right. I'll answer a little bit, Fanny. You probably also want to jump in. So there are, so first of all, you can run the tests. I think what we're describing here is in addition to TR-398 itself, we're also talking a little bit about our implementation of TR-398. Our test scripts certainly assume that the PAL is the endpoint, but let me say, okay, assuming that you don't have the PAL, what could you use? A lot of TR-398 looks at throughput, as you just saw, and you'll see later. So, if you have for example, you can put our traffic generation tool on your endpoint. We have our traffic generation tool we call multiperf. It supports a lot of different traffic generation capabilities, and it has the availability on a number of different platforms, Linux, Android, that sort of thing. So if you use that, you would be able to get a lot of information that is necessary for TR-398, like throughput and dropped packets and things like that. You would not be able to see that second level of information that Prachi was pointing out, things like RSSI, streams, bandwidth, etc. At least not directly. But I don't know, Fanny, if you want to talk a little bit about sniffing here.
Yeah, I guess with the devices, yes, we do want to mention our synchro-sniffing technology, and that we can have 16 sniffing probes in the platform comfortably with one of our testbed PAL boxes. You can put a sniffer dedicated on each real device, and then you could report all of those stats that Leigh just mentioned, MCS, number of streams, bandwidth, etc. Because a sniffer will report it, and we need to position its probe so that it hears the device. So hopefully that answers your question. We do try to accommodate not just the PALs, but provide as much information as we can on the devices that are put in the test bed. Okay, we have another question. It says, what kind of devices, this is from Florian, what kind of devices does your PAL 6 simulate? 3 Wi-Fi 6 devices, or 3 Wi-Fi 5 devices, or mixed setups?
So yeah, the virtual station capability lets you, well, actually, before I do virtual stations, let me just talk in general. So the PAL 6 is it's a chipset-based test endpoint like all of our PALs, and so it's a real Wi-Fi device, meaning it's backward compatible to, as we discussed before, with interoperability to all the other Wi-Fi things. So it can operate as a Wi-Fi 6 device, a Wi-Fi 5 device, and legacy devices, which, by the way, we'll actually show you later in the tutorial. When you set it up as virtual stations, you actually have control over the virtual stations as well. So the virtual stations can be also a mix of devices.
Right. Okay, another question from Mattia. The main issue of working according to the TR-398, in my opinion, is the possibility to procure a stay where is possible to set the test parameters, MCS syntax, NSS, and GI. How can it work outside the whole octoscope solution?
How can it work outside the octoscope solution? Well, we should probably go a little bit into TR-398, which was the next plan here. But let me try and address that. TR-398 is focused on access point testing, and it does, in fact, require that you be able to, set some devices into legacy mode or things like that. It does not specify how that has to be done. We happen to think we have an excellent test bed for implementing it for a number of reasons, which we'll also discuss some more of here, because the PAL is so flexible. But the test plan itself does not describe how you should do these things, right? All it says, for example, is that you need to have, for example, 3 devices that are close, and then another 3 devices that are legacy devices. And how you do that is kind of up to you in terms of creating a test. What we've tried to do is to make it very easy. And again, our PAL devices make it easy because we have that control. I don't know if that's a good enough answer, but maybe I'm agreeing with the sense of your question, which is that it's hard to do, and we've tried to make it easy. Okay,
we have a couple of questions in the queue. From David Herman, how does the setup exactly look like? Do you use 3 PAL 6 with different attenuation to each PAL 6 and simulate 3 Vista, or how do you get different attenuations if you use 9 stations and 1 PAL? I guess
Gotcha.
we have an answer in the slides that
We do. You know, I tried to lay the groundwork before to say it's a little bit out of order because we wanted to start a test for you and show you the test running all the way through, but we got a little out of order. So before I do any more questions, why don't I do a couple more slides and see if we take out some of those questions? Because I think maybe we're getting into like, well, what did we do? So let me, is that okay, Fanny?
I just want to respond very quickly to Michaela, and then we'll leave the other questions for later. So Michaela is asking about the sniffer probes. We had a whole session where we explained our synchronous sniffer, Michaela, but we're happy to follow up with you on how exactly that works. If you'd like to stay later, or just we can contact you after the show. All right.
Okay, so just now we're kind of going to start on some of the more basics here. For anybody who's not aware of the Broadband Forum, it is an industry forum. It's actually very well known. I think it started as the DSL forum quite a long time ago. It's now known as the Broadband Forum. It's most, I don't know if it's most well known. It is certainly very well known for a specification called TR-69. TR-69 is used to control CPE devices, so things like DSL modems or other home CPE devices. It is again, it's a well-known industry group made up of operators, vendors, chipset manufacturers, blah blah. Everybody's there, but it does have a bit of a focus on operators in the sense that the way the group works is it's intended to allow operators to describe what they need and then create tests and other things that will address the needs of operators. So from a Wi-Fi point of view, this TR-398, so this 398 group was created because the Wi-Fi, the operators who are members and who have many different types of operators, some cable operators or wireless operators, but all of them who are deploying Wi-Fi wanted some kind of performance test that they could use. So this is the work's been going on for quite a while. In Broadband Forum terminology, they don't use release 1, release 2, or version 1, version 2. They call things issue 1, issue 2. So issue 1 was actually released by the Broadband Forum TR-398 group in February of last year. So it's been around a while. And what's happening right now, in fact, literally right now, the last week and this week was the most recent Broadband Forum meeting. I think today is the closing plenary. And the group is working on issue 2, and I'll talk a little bit about what's in issue 2 later, or likely to be in issue 2. And the goal is to finish issue 2 by the Q3 meeting. So later this year, we hope to have issue 2 of TR-398. As I mentioned, this was all sort of based on operators trying to get a performance test for Wi-Fi. So the focus is on AP devices. Again, there is no part of the test that looks at station devices. Stations are used to do testing, but they're not part of what's being tested. The device under test is always an access point or residential gateway or something like that. Because it is, again, focused on operators and their deployment needs, this isn't the kind of thing like, the Wi-Fi Alliance always looking at the very latest technology and trying to do interoperability. This is looking at what is actually deployed in the world and seeing if we could come up with a reasonable test plan to look at that. So in issue 1, the 2.4 gigahertz tests only look at 802.11n technology, and in 5 gigahertz at 11AC. Always 2 streams, because that's the primary deployment out there. Most station devices are 2 streams, so it doesn't, again, try to push the envelope on multiple streams or anything like that. It's looking at what's really deployed. And the big thing that differentiates TR-398 from other test plans that may be available is that it's the first that we know of, certainly, where the industry agreed on absolute pass-fail requirements that could be used. So to get to a question that was asked, here's how we implement this. The stack max is one of the larger stacks that's part of our standardized stack portfolio. And we have been using it for all of the tutorials that we've done. We've been showing how it's used in various other kinds of tests. And today we're showing how it's used for TR-398. But this is what it looks like. It's made up of essentially, 5 chambers. You can see 1, 2, 3, 4, 5, big one on top. And then those chambers are all connected up in various ways. When you look at this picture, you can see like these blue cables are our RF cables. You can see things on the side, which are our attenuators or PALs or things like that. And so it's a little easier to understand this picture if we look at it as a logical diagram. But before I show it to you as a logical diagram, let me give you a quick, very, very quick tutorial on how we draw those logical diagrams. So those blue RF cables that I showed you that look like this are usually shown in groups of 4. So a single blue line will be 4 of these RF cables. We have these antennas in all the boxes. You can see our test antennas. If you look around, you'll see them everywhere. They look like this. There's multiple different kinds of antennas that we have. And when we show them in our diagrams, we tend to show them also in groups of 4. So a single antenna like this one here is a group of 4 of these things. Attenuation is done using our attenuators, which again, we tend to show in groups of 4. A single one of our attenuators, you can see it, has 4 inputs and outputs. So it's able to simultaneously attenuate 4 RF lines. This is the symbol that you will see when we're talking about one of these, what we call quad attends. And then finally, the PAL6 is our test endpoint. I've talked about it a few times already. It's our chipset-based Wi-Fi 6 test endpoint. We call it the PAL6. And the symbol that you'll see in the diagram I'm about to show is the one over here that says PAL6 in the middle of it, but that's what we're talking about. So if you look at that stack that I just showed you in real life, shown again here, and look at it logically, I'm showing it now and highlighting in red what elements are used for TR-398. So to get to the question that was asked, this box up here with the turntable in it is where we put the device under test. We then use a set of 3 PALs, one over here, one over here, one over here, as test endpoints. We don't need all 3 PALs in all of the tests, but we do need up to 3 PALs, and so we have them all available. You can see that via the red lines, this device under test is connected to each of the 3 PALs, 1, 2, 3, through different attenuators. In this case, it's through our multipath emulator, which was the topic of, I don't know, maybe our first tutorial, I think. So if anyone's interested, you can take a look at that one. But it also just provides attenuation functionality. So you can think of it in this case as an attenuator and then another and another, connecting the device under test to the 3 PAL6s. So the test that we just did, we just started running that you saw was this multi-station performance test. And the reason I chose that one to run is because it does use so much of the test bed. It uses all of the PALs and it uses the virtual station capability. So the way that's implemented in this test is, we have our device under test up here in the big chamber sitting on the turntable. It's connected to a PAL down here through the MPE, which is actually this thing here. Again, and that's our short distance test. Then when we have to add the medium distance, we use another PAL over here through a different attenuator. Again, 3 virtual stations for a total of 6. And then finally, a long distance test using another PAL down here through a different attenuator, 3 more virtual stations for a total of 9. So I take a little pause here because this question was asked. Does that answer it?
It looks like no more questions, so I'm assuming we answered it. Just a clarification. So you see we have these modules on the bottom of the two small boxes on the left there below, that they make up what we call a smart box. So the PAL6, Leigh showed a photo. It can be outside, independent, fully isolated module, and it can also be built in to the chamber. So you don't need it. Makes the whole test bed more highly integrated, smaller, cheaper, and easier to work with. So that's what those modules are down there.
I'm seeing questions, Fanny. Do we want to take them now?
Yep, let's do the questions. Yes, your question has been answered. So there's another question from Mattia. Inside the octoBoxes, how are the near field effects handled given the physical short distances between antennas and duct?
So near field effects are, they're fact that we are usually in the near field of these testing, but there's nothing that we need to do to, handle them as the question is asked. What we're doing is coupling energy from the device under test to the other endpoints, and that works as well in the near field as it does in the far field. One of the I'm reading into the question, maybe, like, can we support, for example, MIMO in a smaller chamber like this? And the answer to that question is definitely yes. We have MIMO results all the time. We also have a theoretical analysis of the testbed talking about MIMO under near field conditions. So we have no issues, being able to do the kind of performance testing that we're doing, even though we're in the near field of the devices.
Right, and then another question, in what kind is a turntable required for the TR-398 test?
Okay, that's an interesting question. Let me just quickly flip back here. There is a spatial consistency test that uses it. So that one, walks through spins the device under test, I think, in 30-degree steps. And there is, if I remember correctly, I think that the optional test, the receive sensitivity optional test, may use the turntable, I believe. I would have to go back and look. I think so, though. Certainly the spatial consistency one uses it.
Okay, we're clear.
Okay, so what I wanted to do now is go back to the running test and take a look at the output, kind of show you what that looks like, and then discuss a little bit more about how we can analyze the data. So let me see something. Okay, so am I showing the test bed now?
Yes.
Okay, great. So the test has completed, and just to give you a sense of what happens, and you will see us start a test in a minute, but it's very, very simple to start a test. Once the test has been started, you don't have to do anything, and the results will show up here. So we have a log file for the run that we did, and then we did this multiple station performance test. And what you can see here is that we've automatically saved in CSV format our test bed. As Fanny mentioned before, when we run these tests, the test results are automatically saved in our database. We can also export the results, and we can export them in CSV format, among other things. And what you can see here, if you just sort of look, is the various CSV exports for those runs. So remember, I mentioned that this is a short distance test. It has devices at short distance, and then it adds in devices at medium distance, and then it adds in further devices at long distance. And you can see that in the downlink direction, you can see it in the uplink direction, you can see it at 2.4, you can see it at 5. That's why I was saying before, TR-398 tests themselves can be quite complicated. A quote-unquote test may include many, many subtests. We do that all automatically. We also analyze the results automatically. So you can see here in this log file that we analyze the results, and you can see that the short distance test passed. It's telling you the actual measured throughput and telling you what the TR-398 threshold is. So it tells you about all the passing. It actually tells you at the end that all the tests passed in this case. So the test is complete, all the tests passed. You have all of the data if you want it. We analyze it that way. We're also adding in the ability to, let me show you, well, I can do it here, actually. I guess I'll do it here. And I see that there's a hand raised, and I will address it in just a second.
Yeah, Leigh. So can we customize these triggers? Like you said, expected output is this, and what we get is this. So we can customize this somewhere. Well,
TR-398 calls out the expected results, right? So I'm sorry. It calls out the thresholds. So if you want to do TR-398 test as written, you would use those. We haven't built into the scripts themselves the ability to use other thresholds. But that's something that, we could sort of talk about it offline. But right now what we're showing is the implementation of TR-398 as published by the Broadband Forum.
Okay, Leigh, thanks.
Sure. And I'm showing you a very quick example of the fact that we can look at this data in a more sort of graphical tabular format, and this is the kind of functionality we're actually adding to our testbed as well. In addition to the log file results that I just showed you, also the ability to look at this data and get more of a, for example, in this case, graphical view. You can see the short test, with 3 pairs. You can see the throughput that was achieved. You can see the throughput that was required. I think I've picked in some different data, but it's fine. So let me go back. But anyway, this is the kind of view that we're also looking at building. So here's an example of what I was just showing. So you can see the throughputs, the throughput limits, the pass-fail result, or in a more graphical way, the short plus medium, the short plus medium plus long results, along with the TR-398 limits as set. And the question about whether these can be configured is one that we could probably take a little bit offline. We haven't done that yet. Okay, so oh, sorry, am I sharing the right thing? I am. I'm sharing the slides again, right? Yes?
Yeah.
Okay.
You are. Actually, we have another question. Would you like to take it now, Leigh?
Sure, if it's relevant, yeah.
Besides the standard iPerf 3 settings, mode, duration, traffic, etc., the rest, Windows buffer size, etc., is left to the operating system of the test PC. Do you just leave the default values? Is it still a fair comparison?
We use the parameters as configured, as kind of called out in the test plan, and that is true. When we run TR-398 tests, like for example the maximum throughput test, we will set iPerf to run maximum traffic, and if the test plan itself hasn't called out anything else, we do leave it, as you say, to whatever the defaults would be. Is it fair comparison? I think so. I mean, I guess it would be, I guess I'd have to have a conversation about why it might not be a fair comparison. Certainly if you are comparing devices A, B in the same test setup, then the underlying, say, OS will be the same across both, right? So the only difference should be the performance of the device under test. If you're comparing them across systems, I guess I could maybe understand the reason for the question. And we can come back to that one if there's more on it. I'll just kind of forge ahead here, give people some understanding of what's going on in the Broadband Forum TR-398 group. So I mentioned issue 2 focus for Q3 of this year. Here's what's going on. Again, just a slight warning, nothing is finalized yet. So what I'm telling you is what's currently being discussed. Until the spec is done, you can't count on any of these, but here's the kind of things that are being discussed. One obvious one is 802.11ax. I mentioned before, it's the issue 1 looks at N and AC. Obviously, Wi-Fi 6 is a very hot topic, so looking at Wi-Fi 6 in both the 2.4 gigahertz band using 20 megahertz channels and the 5 gigahertz band using 80 megahertz channels is essentially being added to each of the test cases, each of the existing test cases. An additional test case was created to do something that's a little bit special for TR-398, which again usually focuses on things that are really out there in the world, but wanted to look at the peak performance of 11ax. So it is looking at 160 megahertz 2-stream, which by the way is going to be out there in the world. We have a lot of customers that are very interested in testing that. So that one is not really an unusual test, but it's a standalone test. And then this is the one that's a little bit more unusual. There's some optional tests, at least being discussed right now, using 4 and even 8 streams at 160 megahertz. That's very unlikely, I think, to be seen out there in the world anytime soon, 4-stream devices, or especially 8-stream, but that's ongoing conversation. I've said a few times that the TR-398 tests look at the 2.4 gigahertz band, the 5 gigahertz band. They do those tests separately. And issue 2 is looking at adding dual band simultaneous traffic, so 2, 4, and 5 simultaneously. I've also mentioned that the tests will do upstream tests and downstream tests. But again, issue 1 does them independently. Issue 2 is looking at adding simultaneous bidirectional tests. And then maybe the most interesting conversations going on right now for issue 2 have to do with extending beyond the single AP model, going to the multiple AP models. Again, I was describing before how a lot of this is driven by operators deploying Wi-Fi. I think the primary deployment model previously was put an access point somewhere centrally located in a home and try to achieve whole home coverage. Now, of course, there are many mesh and repeater products in the market. Operators are very interested in those, and so there are some test cases being created around mesh and roaming. One test case that's being proposed has to do with looking at the traffic as it flows from an access point through a repeater to the station. So instead of directly from the access point to the station, it will flow through some repeating or mesh device. And then there's a roaming test that is being proposed that looks at moving a station from one access point to another and back, and creating a metric that's trying to get at how long that roam takes by looking at packets that are dropped during the roam event. The reason I think this is interesting is I had mentioned earlier on, I think somebody had asked about, the ease of creating these tests and how we do it with the PALs and things like that. One of the reasons that, we do think we have a pretty nice system for implementing TR-398 tests is that a lot of these tests require like longer distances and things like that, which are very difficult to do in a single chamber environment. But TR-398 does call out both single chamber and multiple chamber environments. For this particular test, for this roaming test, at least right now, the group is anticipating that these would only be able to be done in a multiple chamber environment. Because it's very, very complicated or difficult or possibly impossible to have a station actually move from one device to another device in a single, fairly confined RF chamber. So it looks as though the issue 2 may actually call out that there are some tests that need to be done in a multiple chamber environment. And the nice thing about that, as well as all these other things I mentioned, like 11AX and dual band throughput and things like that, is that the test bed that I already described supports all those already. Right? The PAL6 is already supporting 11AX. We're already a multiple chamber environment, so we think we're in very good position for issue 2 as well.
Yeah, and you may have already mentioned, Leigh, but of course the PAL6 supports Wi-Fi 6 as well. So that's another relevant thing to consider for the next issue.
Yep. So the last thing we wanted to show you is just kind of really how easy it is, at least in this test bed, to switch and a test and run another one. So I'm going to hand this back to Prachi so she can walk you through it. It takes very little time because it is so easy to do. And we're going to do the airtime fairness test. We're going to start the airtime fairness test running, and I'll talk a little bit about airtime fairness as well.
Can you guys see my screen?
Yes, we can see your screen.
Okay. So basically, when we want to switch the test from one to the other, there is this BBF test sequencer file. So in this script, you can see that there are all the tests present in the TR-398. And when you flip the state of individual test from 0 to 1, you can disable one and enable the other. So as you saw previously, we ran a multiple station test. So if I just want to disable it and enable the airtime fairness test, I can just change the state to 1 here and save the file and execute the runme.sh script. And what will it do is it will call the sequencer file and it will run the airtime fairness. So this is the way how you, with a single change in a script, you can change the test case. And the other file which I want to discuss is the parameters file. So this file has all your global parameters. It has all your DUT information. It has all the IP addresses of the PALs and the attenuators you guys are going to use. So you can modify the details here in this file. And one thing about this file is you have to set it just once. Once you set up your test bed initially, and then you don't have to change anything in this file. You can change the sequencer and just execute the runme.sh script to execute the test you want. So yeah, it is as simple as this. Yeah, do you want to add anything or?
I didn't have any more to add. That we just wanted to show you how simple it is to really, make a change, run one test, run multiple tests. And the test we just ran was airtime fairness. We chose airtime fairness. Again, we do not have time to run the whole test for you, but we just want to show you how easy it is to start. But the reason we wanted to call out this one is that it also highlights some of the nice properties, and it has to do with the question that was already asked, actually, of using the PALs to do these tests. We have a DUT, again, same place. We run a baseline test where we use 2 PALs down here that are at the same RF distance from the DUT. We run traffic, and then we use the different attenuator to move one of those PALs, quote unquote, move it further away, or we can leave the attenuator the same, and we can use the fact that the PAL is configurable to change it from, say, an AC device to an 11A device. So we move it, or we turn it into a legacy device. And again, that's very simple to do with the PAL. And when we do that, we can, we get a bunch of data. Again, many tests are run. We were running traffic to 2 things. We're moving things. We're creating legacy things. We'll have a lot of data. We can pull all of that in, and you can see, for example, that in this example of that test, we ran our baseline test. Everything looked good, passed. We moved one of our stations So you can see station 2's throughput goes down as expected. It's further away, and the test passes based on the requirements from TR-398. Then we changed one of our stations into an 11A station. You can see that in this case, one of our stations got the lion's share of the throughput. The 11A station did quite poorly, and that actually failed the requirements. The threshold, sorry, the throughput limit passed, but that particular part of the test failed. So we had a bit of a failure there on the legacy. So and that may well be how the AP is actually handling airtime fairness. So just shows an example of an actual fail. Again, the whole test doesn't fail. I mean, whole test does fail, but not each subtest. And so you can see all that detail. So yeah, to wrap up, we're coming near the end. Just wanted to, hopefully we gave people a good summary of what's going on in the Broadband Forum and TR-398. Again, it is, as far as we know, the first industry-approved performance standard for Wi-Fi. We have seen very robust adoption. We have a lot of interest in this from our customer base. Right now in the group, as I tried to show you, the Broadband Forum group is working on updating the specification to include newer technologies and expand the reach a bit for different topologies of deployment. And the pass-fail results are sort of under constant review to make sure that they are accurately reflecting what products are able to do out there in the real world. So I guess finally, to wrap up, our next topic that we're planning to do is to discuss antennas in the testbed and various things like multi-user MIMO. This may be a topic that is interest to the person who asked about near-field effects and things like that. And again, if anybody has other topics they would like us to cover, please feel free to reach out and let us know. With that, I think we are done, and happy to answer other questions.
We have a raised hand from Naveen.
Yeah, Leigh. So my question is, so there is no test plan for current measurement in TR-398, but we have seen a lot of requirements from different battery-oriented customers for WLAN chip. So any plan for implementing the current measurements for them?
Okay, so you're talking about actually measuring power draw, that sort of thing. Is that what you're talking about here?
Yes, yes, by wireless chip.
I think I may hand this back to Fanny. It has come up in our conversations in the past. I don't know. I mean, well, let me talk about it from the Broadband Forum point of view. No, from a Broadband Forum TR-398 point of view. At least it's not on the table right now. Of course, anybody's welcome to join the group, and that is something that could be suggested or added, but it's not on the table from a Broadband Forum TR-398 point of view.
Okay, I would just add that this test power draw mostly applies to station devices, and TR-398 is targeting router EP devices, and where power consumption is not critical. But it is an interesting test case. We are thinking about it. It's a good question. I got a couple questions here, actually 3 open questions, Leigh, in the Q&A. The first one from Mattia: will be the penetration performance test restored in the future?
The penetration performance test? I'm not sure I understand the question.
It doesn't look like we have it in the list. So I guess the way I'm interpreting the question is, will it be added, maybe?
Again, I think I just must be misunderstanding the question. These are the tests that are called out in issue 1. I don't know of any tests that were removed.
Yeah, so Mattia, please feel free to clarify or raise your hand and we'll let you speak. I have a question from David Herman. Okay, sorry, I just scrolled right past it. So the first one, there are 2 questions. Can I do the MU-MIMO test with only one PAL6 which simulates two MU-MIMO vistas, for example. Maybe this is part of next Zoom session. You want to take that one first, Leigh?
I will take it. So I will admit that I jumped over this a little bit when I was describing the elements. Although we do have, I did fairly highlight these stay pals over here as TR-398 elements. I just did not actually specifically call it out. So maybe it's something for the next session that we would need to talk about. But the highest level answer to your question is this: the PAL6s, although they can be operated as stations, cannot at the moment be operated as multi-user MIMO clients. So we have these other devices in here called stay pals. Those are also chipset-based PAL devices, but they're very specifically station and sniffer devices. And they do support all the station functionality like multi-user MIMO and OFDMA and things like that. And so when we do the multi-user MIMO test, we actually use 3 of the stay pals that are located as part of this stay pal group. So it's this guy, the device under test, talking to 3 different stay pals. That's how we do that test.
And then the second part of David's question is, when will it be possible to configure Vista via GUI? Because with last update I got from May, the Vista feature is available, but only via API. So if you're not a programmer, it's really hard to get working. Maybe I can take that one, Leigh.
That would be best.
Yeah, we have a new release, and that's going to be available in a month. That, yes, allows you to configure Vistas via GUI. However, I would add that Vista, I mean, if you can have 96 of them in a PAL6, and it does get tedious. So scripting is an easier way to go for a lot of Vistas. So. Okay, so let's see what else we have. We've got Wojciech Romek asking, will TR-398 have new acceptance criteria for airtime fairness with OFDMA? Good question.
Right now, there's no, at least issue 2 does not get into OFDMA testing yet. I mean, I think the answer to your question, if you're asking it generally, is yes, it should. I just don't know what issue that will be. I think the industry is still trying to get its head around how to test OFDMA the best way. I think we've actually done a few tutorials that touched on OFDMA testing as well. And the TR-398 group will, need to, as a consensus-driven organization, it's going to need to figure out what the right way is of testing OFDMA. So issue 2 will talk about 11AX, but there's no specific OFDMA call out, right? So it's going to be things like throughput and multiple station, but although the existing tests except run with 11AX. So I think OFDMA won't be part of it yet.
Okay, and Matthias clarifying his question about penetration, Leigh, he says it was in the draft but has been removed. So he wants to know if you guys plan to reinstate it.
The draft for issue 1 or issue 2?
I'm guessing issue 1, but.
Okay.
Yeah, he says issue 1.
For issue 1, and this was the sorry, what was it called again?
Penetration test.
Okay. I will have to go back and look, I guess, at some of the older ones. I have not seen anything in issue 2 discussions about it. But you know what? Contact me offline. We can talk directly, and I should probably know about it anyway. I'm not aware of it, and I haven't seen anything in issue 2.
All right, folks, I guess we're up a little bit over time. I think we got all the questions, but again, feel free to.
We have one more in our chat. It says, as you said that the forum is working on dual band capability, issue 2, do we have any update on that?
Update in what sense? I don't think I can actually expose the details of what the group is proposing, I'm pretty sure that's not, probably should not be allowed, but I think it's okay for me to say that in general, dual band throughput and bidirectional throughput are test cases, but I don't think it would be right for me to disclose the details of what's being discussed until it's public. But if you're a member of the Broadband Forum, you can of course look at the drafts.
All right. Okay, and well, thank you all for joining us and for your questions. I see there may be one more. It says PAL6 is also 6 gigahertz capable for 6E from Zishan. It's not. It's not. You will need to add a 6E PAL to your testbed, but that's not hard to do. Okay. So folks, thank you very much. Again, we're delighted that you've joined. We'll be doing 2 more sessions live today, and we will be posting a video. Bye-bye, everybody.